All right, guys. These are your notes for quarter number 3, week number 1, heat transfer part 1. You also have your introductory video. You're supposed to make a 1-minute video introducing yourself. Make sure you turn your camera on for that, and then submit that to the introductory video assignment. This one here, everything that's in yellow needs to go to your notebook. Answer them in your notebook, and then snap a picture of it and submit your answers to this assignment. Okay, heat transfer part 1 notes. So these are your questions. You're going to answer these 10 questions basically for your notes. The first picture that you have shows a picture of, on the picture on the left, has a heater, a heat source, which is red. This is all in infrared type of photography. So red and orange and yellow show heat, and the arrows are going up on the left because the heater is on and hot air rises. The picture on the right, the colors blue and green represent cold colors, or purple represent cold, and you'll notice from the window the arrows are pointing down because cold air sinks, and cold air coming from the window sinks to the floor. What is heat? Heat is energy of molecular motion. So that's what you'd want to write that for that. Heat is energy of a molecular motion. All atoms and molecules are moving, they're vibrating, and when heat is added, molecules speed up. When heat is removed, molecules slow down. How is heat measured? I have the words outlined here. The units for heat are joules, heat energy, joules. You have calories, which is a small c, and 1 calorie is enough energy to heat 1 gram of water 1 degree Celsius. So that's a key definition there. Food energy is also calories, but that's with a capital C. So a capital C food calorie is actually equal to 1,000 small c energy calories. The British thermal unit, or BTUs is typically what they're called, is another way to measure energy in the English system, and it is equal to the amount of energy needed to heat 1 pound of water at 1 degree Fahrenheit. So we've got the same thing that's being measured except different units. So for the BTU, we're saying 1 pound of water, 1 degree Fahrenheit. But for the calorie, up here in the second definition, we're talking about 1 gram, not 1 pound, but 1 gram of water, 1 degree Celsius instead of Fahrenheit. So those are the differences in those units between calories and BTUs. I'm going to go skip a number of the pieces of information here. BTU, you can convert it into joules. Okay, there are 1,055 joules in 1 BTU. How do we get to that? How do we get to that number? Well, let's do the math, and you'll see if you're looking in Schoology, there is a link there that you can also see the math being done. I think Mr. Lindfors put that in there. But 1 BTU is equal to the amount of heat that it takes to raise the temperature of 1 pound of water 1 degree Fahrenheit. Okay, so we can convert. We're going to have to convert. We're going to have to get from BTUs to joules, and we're going to pass through calories in order to do it. Okay, so we're going to use conversion factors here. The first conversion factor that we'll talk about is going from pounds to kilograms, and that's right up here. We see that there is, for every 1 pound, we have 0.454 kilograms. Okay, and that gets rid of pounds. The next conversion, we're going to have to go from kilograms to grams, and we know that for every 1 kilogram there are 1,000 grams. Cancel out kilograms. Okay, the next one that we will do is we're going to go from degrees Fahrenheit to degrees Celsius. Okay, degrees Fahrenheit for every 1.8 degrees Celsius, it's 1 degree, degrees Fahrenheit, it's 1 degree Celsius. And that will get rid of degrees Fahrenheit from our original numbers there. Okay? And then we would say we will say that for 1 calorie is the amount of energy it takes to raise the temperature of 1 gram of water 1 degree Celsius. And that will get rid of degrees Celsius, and that will also get rid of grams. Now we need to convert from calories to joules. And this is right here, right up above here. It says for every 1 calorie, there are 4.184 joules. Okay. For every 1 calorie, there are 4.184. Oh, where'd that go? Joules. Sorry about that. Let's do the math. We're going to have to multiply just the numbers here. We can ignore 1 because everything multiplied by 1 or divided by 1 is still 1. 0.454 times 1,000. We're going to have to divide by 1.8 and multiply by 4.184. Okay, so let's take a look at this here. 0.454 times 1,000. Oops, I don't need the decimals there. 1,000. And we are going to divide by 1.8. And then we had to multiply by 4. I suppose I should put the multiplication in there, right? Multiply by 4.184. And if you look at the answer there, it's 1,055. And that's the math showing exactly what we saw here up on the top. That 1 joule is 1,000, excuse me, 1 BTU. 1 BTU equals 1,055 joules. And that's showing you the math there. What is temperature? Temperature is a measurement of how fast molecules are moving. That's what you want to put in your notes. Low molecules will slow, low energy, low temperature. High energy, fast movement, high temperature. We measure temperature in degrees. Okay, we use the Fahrenheit scale in the United States, Celsius scale pretty much everywhere else. In science classes, we almost always use the Celsius scale. We also have the Kelvin scale, absolute zero, and 0 Kelvin is also called absolute zero, which means the absence of any kind of molecular motion. Okay, a little algebra practice, deriving a unit to get the temperature in Celsius from Fahrenheit. So you've got this conversion right here, which is if you're given a temperature in degrees Celsius, how do you go to Fahrenheit? And the answer is Celsius times 1.8. You can put that in parentheses and then add 32. If you want to go the other way, you go from Fahrenheit to degrees Celsius. You're basically doing just the opposite. You have degrees Fahrenheit and you subtract 32 and then you divide that by 1.8. So let's take a look at a couple of examples here. The first one here, freezing water. Fahrenheit is 32. I'll just tell you that, and you need to convert that to degrees Celsius. But let's do the second one. Room temperature is 72 degrees Fahrenheit. So we'll use the second scale here. 72 degrees Fahrenheit minus 32. And then you'll divide that by 1.8 to get the answer. 72 minus 32, and we want to have that in parentheses, and divide by 1.8 is 22.22 equals 22.2 degrees Celsius. That's room temperature. 22.2 degrees Celsius. How about going from boiling water in Celsius to boiling water in Fahrenheit? Okay, so you would do 100 degrees is boiling water times 1.8, and then you will add 32. Gives you 212. 100 times 1.8 plus 32 equals 212. That's how you do the math. You can do those other conversions. You can go online and find some direct conversions that does the math for you, but it's good to know how these numbers are derived. Okay, three ways that heat moves: conduction, convection, and radiation. Conduction, what you want to know for this is that it is temperature moving, or heat moving through touching. Molecules touch each other, okay? They shake each other and transfer energy, okay? So faster moving molecules are touching slower moving molecules. They transfer their energy. The temperature rises, okay? That's heat of conduction. Heat of convection is heat moving through a fluid, okay? It's called fluid movement. Okay, so hot air rises, water as it heats molecules begin to move faster, and they flow. So it's movement, molecules in a fluid moving and carrying their energy with them. That's convection. Radiation is heat of the sun and lamps, light. All objects give off radiation. Hot objects give off more radiation than cold objects. If an object receives more radiation, then it warmed. Excuse me. Let me erase that. Object receives more radiation than it gives off, then it warms up. Okay, and then let's see. Direction that heat moves. This is the key point on the bottom here. The last one is that heat always moves from a hotter to a colder. Whether it's conduction, convection, or radiation, it can move in any direction. Natural heat movement is that hot air rises, okay? But heat moves from high temperatures to low temperatures. So that's it. If you guys have any questions, make sure you write emails, get in the Google Meets, but let's get off on the right foot and get these assignments turned in. Good luck.